Hey there, Vince Manship for the Group Training Academy powered by AVI. Thanks for looking at this video with me. I'll tell you what we're going to talk about today, and that is voltage drop testing using a scope. Now I'm using my Launch X431 Throttle 3. I love this scope, but there's lots of scopes out there. You can do this on any scope. It doesn't really matter to me what scope you're using, but the key is looking at that voltage drop. And the reason I bring this up is I've started to see more and more failures on older cars because of corrosion in really weird places. And I did a little segment in an Introduction to Lab Scope video recently where I talked about how to hook up your scope. And if you hook up in the wrong place, you may not see it. If you think about it, if you're measuring a signal on an output device, what's an output device? We're talking about a fuel injector be an output device. Would I be better off to hook my scope up at the computer to get that pattern or at the injector? Where would I get a picture, or would it matter? Well, if it's amperage, I can go anywhere, but if it's voltage, if I'm trying to figure out where to put my voltage lead on an output-driven component, I want to be as close to the component being controlled as possible. Because remember, my meter or my scope, depending on the tool, is only going to see what's between the meter leads. So my battery ground, which you can't see just off camera there, and where I hook up. So if I just go to the computer, there's a whole length of wire I can't see, or I should say the scope can't see or the meter can't see. You want to be in here. But what if you have problems in this connector? All right, so let's get a good look at this. So if I think about this connection, yeah, it's nasty, it's dirty, it's old, but what about when somebody over time has back probed and back probed and back probed, or you happen to buy a rental car that I rented once and used for case studies. The point is somebody's damaged this weather pack in here, or somebody loves their pressure washer. I had a customer like that, did a lot of wiring repairs on this person's car. They pressure washed it every weekend and water would go down in here, and so we had a resistance problem in the connector. So when I back probed it, the signal looked great, but you got to get on the other side of it. It's not always about where's the easiest point. Now, a couple of things you want to think about is getting a set of leads like I have here. This is set up so that it's got the terminal end that fits in this connector. The nice thing about it is twofold. One, I can do a drag test. I can actually plug it in as if it's an injector and then pull on it and just see, are the terminals even holding anymore? Terminal tension's becoming a big problem, especially on older cars. The other side of this has a nice banana jack. You can actually connect your lead to it, and there you go, so it makes it easier to do testing. The nice thing about doing this way is now I can be in the circuit. So let's take a look at what I've got down here on my board. A lot of stuff going on here, but let's just focus just real quick. So here's my connection that would go on my injector. My fuel injector is over here on the side. You can see I've taken the driver circuit now, and I've just added a jumper wire to it. And then on the voltage circuit, because the problem I'm seeing is voltage drop, really where I want to talk, I've added a resistor. Now it's a little hard to see, that's fine. This is a 22 ohm resistor. Now, how do we know that? Well, because it is, and you're going to have just a little bit of faith in me that I'm not lying to you. And if you know me, maybe that's hard to do. But my point is, I'm going to show you some things here. So I'm going to turn my scope on here. Now, if we go look at the scope, just kind of close in on that, there's nothing happening here. I have all my channels turned off. This is going to be really something that's only going to work for you knowing what I'm pushing. So that's why I'm not showing you what I'm actually going to push. If you're using this scope, you have to get comfortable with your scope. But I will tell you, I'm going to use channels 1 and 2, so I'm going to turn those on, and so now I have those channels on. Again, doesn't matter what I pushed, because if you're not using the Launch scope, it's really immaterial. My point is, the channels are on now. I can see something. A lot of scopes will they'll pick up whatever noise is in the air. If I touch the lead, it'll alter the pattern. Now I'm just holding the lead. If we take a look at that, that's all I'm doing. It's just, I'm noisy, I talk a lot, so it's picking that up. So don't worry about that. It'll go away once we're actually hooked to something, and let's do that now. So I'm just going to go ahead and hook to the power coming out of my connector. So I'm in the connector here. My power lead's coming out. I'm going to hook to that. My pattern just went off the screen. What do I need to do? Well, notice that I only have, we get in close, you look up the left side of my screen, you'll see the yellow numbers over there. Right in the center shows 0 volts by the number 1, going up that left side to 10 volts. That means I've got my scale set to where I'm only seeing positive 10 volts up there. So I need to just change my scale a little bit. Now you can see I've changed my voltage. I'm setting now at 5 volts per division, so I'm showing a max of 25. Now you can see my solid yellow line. I'll move it back and forth here. It's going power, ground, power, ground. So you can see it change in there. So now I'm reading it. How much voltage am I actually reading? What is that value? So in this case, I'm going to use my trigger for that. So up in the top, and I'm going to circle kind of right here, you can home in on that. It's showing you what my values are. So I'm going to grab a hold of my trigger point, and you can see the numbers are changing. Let's zoom in on that scope. You can see my numbers are changing in the Y2. That's going to be my trigger, or my cursor number 2. And I'm going to put the power back on it here. And I'm going to line this cursor up with that power line. And it's showing me that Y2 is 12.76 volts. So now that tells me that's what my point was. Okay, fine. Now 12.76. Now I'm going to go, and watch as I do this, I'm going to go now to the other side of the resistor. I was testing it before the resistor, just coming out of the connector. Now I'm going to go to the other side of the resistor. Remember, it's 22 ohms. And what is that voltage value? Now I'm on the outbound side of a 22 ohm resistor, and I still have 12.76 volts. How is that possible? Well, remember, it's understanding electricity, really, because I'm going to get to how this is going to look here in just a minute. Remember, resistance resists what? What does this thing do? Does it resist voltage or current flow? Resistors resist the flow of current. There's no current flowing right now. The injector's off. This could be a billion ohms, doesn't matter. It's not resisting anything, because resistors resist current flow, not voltage. The voltage that changes, the drop, that's an effect of that resistance that's happening. You're seeing the amount of energy, the voltage being consumed through that resistance. That's voltage drop. So let me show you what that's going to look like. Here's where I had this problem on the car I used in the intro video. Again, check that one out, Intro to Lab Scopes. So in this case, this resistance is actually happening literally in this connector of the injector. It's happening above the, or below the weather pack in here. So when I back probed, I had a clean set. So that's like, let's say I back probed and I was connected here in a nice clean piece of metal. The problem is between the injector and the connector. So if I'd used a test lead like this, which is what I ended up doing to verify it, even though I used amperage to find the problem, my point is, let me show you what that looks like. So on my scope, I'm going to trigger this injector, and just so you can see it happen, I'm going to hook up my signal lead to the signal side so you can see it's actually going to run. Those dropouts are just me hooking up. So I'm going to hit the trigger. You'll be able to hear it probably. I got a lot of things happening there. Ooh, that's a mess. Can I make anything of that? No. Let's go ahead and change my time base a little bit here and see if we can make something else happen. That's better. Let's go a little more. There we go. Now we can really see something. See some events happening. So I'm going to hook up to the power, and as you can see, I'm on the input side of that resistor. So that is as if I were back probed into the back of my connector, just like you normally would on a car. You're going to go into the back of that connector. And I've got my voltage signal. I'm going to activate my injector. Notice the injector in the blue was tracing. I'm going to do it again here. We'll zoom in. In the blue, that's my trigger channel. You can see the injector is being turned on, but that voltage was not moving off of 12.76. Now I'm going to go to the other side. So set up like this, where I have taken my injector and unplugged it, put my test leads in, and actually used where the injector is plugged into it. I'm going to come now to this side of the resistor, and I'm going to hit my trigger and watch what happens. Okay, and I'm going to hit it one more time so we can see it. And I'm going to capture it. Okay, so now I've stopped it. So what am I seeing here? Notice that every time I had the ground pull on the trigger, so I'm seeing the voltage pull to ground just like I would. There's no spike because this tester's clipping the spike. Don't worry about that. But it's pulling. And then here you can see the voltage. This is where the term voltage drop comes from. How far down did it go? Well, I can use my cursors to figure that out. I can go in and just grab Y1 and just pull that down to the bottom point. It pulled all the way down. Y1 is now showing. Let's take a zoom in look at that. Y1 is showing 6.51. You can see that up in my block of yellow data there. So it's pulling down. So 6.5, which tells me that 6 volts is being consumed in that 22 ohm resistor. Now, I didn't see it when I was on the connector side of the resistor, because the meter can only see a problem when it's within the meter lead's measurements, which it couldn't see. The resistor was after where I was measuring. So the voltage in the circuit from the fuse box all the way through the wiring and all the connectors, all the way up to that resistor, there was nothing wrong with it. It wasn't until I got on the other side. And to do that, I had to get into the connector, right? I had to open that thing up, plug in like I were an injector, and then that's when I was able to see the problem. So that's the issue with making sure that you've got your scope set up in the right place, the actual hookups, and how you can use your scope to find a voltage drop. I hope that was helpful. For the Group Training Academy and powered by AVI, I'm Vince Manship.